get it if I want it. Gotta make to myself a promise.
Welcome to Chip Logic Studio, and as you see in my previous video, this is part 2 of APB Protocol Assertions and SystemVerilog. So phases was completed in our previous video, and in this video we will check what is remaining. So in APB protocol, certain signal may remain stable during the specific phases of a transfer. Means we have completed our phases like phase, idle phase, after that our access phase or transfer phase, like that. Now we will check our signals, that if our signal should be stable for that part of phase or our signal should be unstable, then we will check that. Any glitch or change in this signal during transfer can cause a protocol violation and incorrect data transaction. As you can see, the specific our FSM says that if this signal is 00, then idle phase will be there, like P select or P enable. But it doesn't say about our other signals, what are they doing when these two signals are there. So we will check our other signals as well. Using SystemVerilog assertions, we can enforce that these signals do not change when the transfer has begun. So we will check our transfer, how it's transferring our data with the help of our control signals, and this behavior we will check with our assertions. This ensures our correct handshake behavior and prevent design bugs related to HTTP secrets. So let's begin our checking. So this is our first. So parametric property to check signal is not X or Z. So in our transfer, we don't want our signal to be unknown or high impedance. So we will check dollar is unknown. It is our system task. We can use in that if the signal, any signal is unknown or any signal is high impedance, so it will check and it will give error if the property is violated. Means how is the property violated? At every process of clock, it will check if there is a reset. If there is no reset, then it will check that if signal is unknown or not. If it is unknown, then it will give an error. It means our assertion will fail. If it is not unknown, then the assertion will pass. Next is our parametric property to check if signal is stable during the transfer. Means we will check our property that signal is stable or not. If the signal change means the state become idle or setup, that is the transfer just means. So let's check our assertion. Our parametric generic stable means our signal should be stable. This is also system task used in assertion, that is $stable signal. Whichever signal we want, we can check that it is stable, and at the next clock cycle, if it is stable, the signal is stable, then setup phase or idle phase should be there. So it is simple assertion. The first line is same for all the assertions, and second is our using of $stable. So in this part of video, I will just tell you about the unknown or stable. This type of system task we can use for checking our different signals. So it is simple assertions like $stable signal, and setup phase or idle phase should be there if the signal is stable. Next is our property PW data. So we will check our PW data in write transfer, and first line is same for all the assertions, and here stable. If not stable, then this assertion will fail. Means it is stable condition we will check, that is at PW data at next clock cycle. P write means not of P write, means if P write is 0 means read, or setup phase or idle phase. Means if it is not 1, then setup phase or idle phase should be there. If it is right, then transfer stage should be there. So up till that, our P data should be stable, because if P data will come, then only we can write something. For P enable and P select, this is assertions for that signals, and first line is same. And for $fail, this is another one system task like $stable. $fail means it will go from 1 to low, means high to low. So if this thing is visible to our $fail, then this assertion will fail. But it is not of not. It is like $fail direct P enable. So it should not fall. So if P enable fall in next clock cycle idle phase, or means if P enable is fall, then next clock cycle idle phase should be there, or $past of P enable and $past. This is also our system task which will check our previous cycle, and this P enable and P ready should be there. Means which condition it is? It is a transfer condition. If it is not there, if it is falling, then this condition should be our past conditions, and it should be at idle phase. So this is this assertion transfer. P enable in transfer means Here your idle condition is there. After that there is setup condition is there. After that this transfer condition is there. So p enable, if it falls like this, then transfer condition should be there, and transfer condition we need our p ready. So whenever these two signals p select and p enable is 1, then p ready signal should come there at pass cycle, and in this cycle p enable should fall. So this is the assertions we are talking about at transfer stage or state. So here is our last assertion of p select stable in transfer. Like previously we check our p enable is stable or not. Now we will check p select is stable or not. So this is our, every line is same for every assertion, and here we will check like not of p select means p select is 0, and then at past p select, at past p select means now we will check when it is 0 and dollar pass p select means dollar pass whatever p select is there. At next cycle dollar pass previous cycle p enable, previous cycle p enable, and previous cycle p ready. So this assertion is checking that if the signal is stable, p enable is 0, previously also 0, or p select is 0 at past p select, and then means ending of this logical ending, and at dollar past p enable and p ready, if these signals are there or not. Transfer stage, focus on transfer stage. In transfer stage, or we can say before that we will say our setup stage, our p enable is 1 and p select is also 1, and this is our pass condition. So it is checking that this pass condition is there or not. When p ready is available means output is available, when these two are 1, then this signal should be stable, that p select and p enable is stable. So what is it saying? Check if p select stable during transfer, that is p select can fall only after transfer is completed, means after this setup and transfer, then only this p select and p enable can be fall, means from high to low. This condition can only occur after transfer stage. So this is that two assertions are talking about. So this is whole assertions, and you can write if you added a few more signals like APB 3 or a new version of APB, you can also include the assertions for that. The simple conditions are there for checking the behavior of a signal, and you know if the specification says that this signal should fall at this time, so you can write assertion now. And you, as previous video, you can also use assert keyword for initializing this assertions like property, and you can also write sequences, and you can mix these all signals and also write your p select and p enable simultaneously. And there is a wide variety of coding styles, and whichever you prefer is good for you. So thank you, and we will meet at next video.
Quick, I don't give up, I won't give up this, cause I know that I want it, know that I'm on it, I'll make it, I promise.